When network, transport, and application protocols were first created, developers didn't anticipate that they would be exploited by attackers who wanted to gain unauthorized access to networks. These protocols, whether used on a private network or on the Internet, make a network vulnerable to intrusion. For example, the TCP, UDP, HTTP, and FTP protocols send data as plain text. This makes the data, including sensitive data such as passwords, vulnerable to packet sniffing. Spoofing is also a risk when you use these protocols, because they don't include authentication functions. Some solutions that have been deployed include updates to protocols or new design workarounds. Another solution is to use entirely redesigned protocols, such as IP version 6. However, it's often difficult to implement such changes, as they could affect the interoperability of some of your systems. The Open Systems Interconnection, or OSI reference model, describes how data from an application on one device moves through a network to an application on another device. The OSI model is considered the standard architectural model for intercomputer communications and is referenced for developing and understanding almost all networks in use today. Network, transport, and application protocols operate on the relevant OSI layers. For example, transport protocols provide data transfer capabilities on the transport layer. The OSI model divides the tasks involved in moving data between devices into 7 techniques or task groups, which are each assigned to a specialized layer in the model. These layers enable systems to implement each task independently and simplifies the design, development, and troubleshooting of tasks. The OSI model includes 7 layers. The physical layer of the OSI model is the fundamental layer upon which all higher-level functions in a network are based. Unlike the other layers, which perform functions that implement various protocols, the physical layer defines the actual network hardware required for data transmission and the protocols required to convert raw data into signals that can be physically transmitted. It's the only layer at which data is physically moved across the network interface. The network model that was created to define the U.S. Department of Defense's Advanced Research Projects Agency, or DARPA architecture, became known as the DoD, or sometimes DARPA model. The DoD model uses TCP/IP protocols to exchange data, and is therefore often referred to as the TCP/IP model.